Hello everyone, and welcome to my channel. This channel is for educational purposes, and we like to look at theories of everything in depth. All-encompassing theories, magnum opuses, and the like that you probably don't know about because they've been suppressed and can only be accessed through a lot of digging and a lot of, kind of poring over the material with nobody to help you. And, the stuff is there, it's out there, but it's difficult to access. Today is our 364th video that we have done on the reciprocal system of theory. And the reciprocal system of theory was originated by Dewey B. Larson back in the 20th century. Put out his two fundamental postulates in the late 1950s. And from there, set out on a path of deduction, took his two simple postulates and from them derived a theoretical universe about how the universe would behave if his postulates were correct, and then compared those in his books, compared those findings, his theoretical universe, with the actual universe that the scientists had discovered through their observations and measurements. Especially, he did a lot of comparing of the tables, the scientific tables of, he's got a book that's called Basic Properties of Matter that we're going to take a look at pretty soon here. And, in that book, he has the first chapter is called compressibility. And, the first chapter is called Solid Cohesion, and then his second chapter is called Distances, Interatomic Distances. And so he compares his theoretical derivation of the interatomic distances of elements with the actual published scientific tables that the mainstream scientists had come up with for that they produced in a laboratory. How far apart these atoms are in their various orientations and in their various states. And it's actually kind of amazing to look at how his correlations are so accurate, given that he's just pulling them out of his theoretical, matrix or whatever, that he's not using a laboratory, but he's in many cases coming up with tables that are as accurate as the, where they agree to 0.1% of the values of, these people that are measuring this stuff in, like, for real in a laboratory, where he's able to make theoretical conclusions that are concrete, or just about concrete. And in many cases where they differ, he's able to show that his results are actually correct and theirs are wrong. So it's pretty interesting. We'll get to some of that basic properties of matter later. Most of what we looked at has been more theoretical, and it's all theoretical. But today we're reading an article from Dr. Bruce Peret, who is one of Larson's chief revisers. After Larson died in 1990, Peret kind of emerged and stayed within the spirit of the reciprocal system, but made some key adjustments to some of the many updates. Updated the system based on some new findings and some new techniques that Larson didn't know about, or maybe Larson did know about them but didn't really want to bring them up, such as non-Euclidean geometries, projective geometries, computer imaging, Chinese Taoism, a lot of different things that Dr. Peret brought to the table that Larson didn't. And I think that Peret did a great job of kind of updating, re-evaluating the reciprocal system and making some key changes. But first, we'll just try to figure out what Larson is actually saying in his two fundamental postulates. The first postulate, which is by far the more important of the two, is that the universe is composed entirely of one component, motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. The second postulate is that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Now, just to clarify a little bit, Larson basically revised his own postulates several times over the next 30 years before he died. And so, you know, I'm not quoting Larson verbatim. I don't believe, maybe I am, but, you know, he tweaked his postulates several times between 1959 and his death in 1990. Changed around a few of the words and, you know, put in a word here or there. He originally started, instead of saying that the universe is composed of motion, he originally started by saying the universe is composed entirely of space-time. He eventually came around to say, instead of saying space-time, he said motion, and that motion has 2 reciprocal aspects, space and time. Eventually, later on in his life, he didn't officially change the postulates, but he came to recognize that what he's actually talking about was not even motion, but change in 3 dimensions. So, you know, it's difficult to present Larson's fundamental postulates because he changed them several different times. And now his second postulate is very much under dispute from some of his revisers, especially Dr. Bruce Peret. I mean, Dr. Peret died back in 2020 as well, but before he died, he made some big changes to the second fundamental postulate, including getting rid of the Euclidean geometry part and putting in projective geometry instead, and that the projective geometry actually includes Euclidean geometry. So Euclidean geometry is a small subset of projective geometry. Now, I guess one thing that I would say about the postulates is that I would have put in a qualifier, an adjective to the word motion. The universe is composed entirely of motion. I'm not sure why. I'm sure there is a reason. I don't know what it is. Why Larson didn't say scalar motion or perhaps progressive motion, or non-local motion, or something like that, instead of just a motion. Because normally when people hear the term motion, they think more of a vectorial motion, a motion that has a specific direction. But the motion that Larson is talking about is specifically a non-vectorial motion, what he calls a scalar motion, which is a motion that has a magnitude but has no specific direction. And a scalar motion can be visualized using a balloon with dots on it that I've gone over a million times, but it's still worth thinking about. If you blow up the balloon, all of the dots are moving away from each other, but they're not moving in any specific direction. And, if you suck in the balloon, all the dots are moving toward each other, but they're not moving in any specific direction. That is a scalar motion. Time also is a scalar motion. Time is always getting later and later and later and later, but it's not moving in any specific direction. Or if it is, it's certainly not moving in any space-like direction. And Larson refers to these as progression. He calls it the progression of the natural reference system. And he refers to these as clock time and clock space. The clock is always getting later and later and later. Space is always getting farther and farther and farther apart. So, and that, that motion has been observed, not just in this hypothetical balloon, but also the distant galaxies have been observed to have been moving away from each other. So it's kind of criminal that the scientists have not investigated and emphasized scalar motion more, and have just kind of treated it as an anomaly, whereas Larson is putting it really at the center of his entire theoretical universe. Now, also, space and time are reciprocals of each other. So that's where he gets the name of the reciprocal system. And that also means that space and time, basically, they multiply to be one, like all reciprocals. And they have the same general qualities, like all reciprocals. And so what Larson knows about space is that it is basically three-dimensional. That's why he says existing in 3 dimensions. That's what he calls coordinate space. But since space is 3-dimensional and it is the reciprocal of time, then time is also 3-dimensional. And that actually was kind of a leap that he made in his findings early on that propelled him to kind of propose the reciprocal system, is the 3-dimensionality of time. And then time and space are both quantized. They both have a minimum unit, and you have to have a full unit of either space or time or motion to have anything. And if you have exactly 1 unit of space in 1 unit of time, space over time being speed, the car is moving 15 miles per hour, 15 miles of space in 1 hour of time. 1 unit of space in 1 unit of time is the speed of light. Larson refers to this as unit speed. 1 over 1 equals 1. And this unit speed is really the background of this universe of motion that Larson is proposing. That it is the state of rest of the universe. if you don't have anything, if you have a featureless uniformity, you still have the outward progression at the speed of light in all directions. Larson refers to this as the progression of the natural reference system. And this is where, this is his reference point. This is where he makes measurements from. So where the legacy scientists are making their measurements from 0, Larson is measuring from 1. Just like you would in a reciprocal system. The center of a reciprocal system is 1. On the positive side, you have 2, 3, 4, and 5. On the negative, you have 1/2, 1/3, 1/4, and 1/5. They multiply to be 1, but unlike the legacy system that is measuring from 0 and has +1, +2, +3, on the negative side, -1, -2, -3. They add to be 0. So the reciprocal system is a multiplicative system. Okay, now the article that we're reading from Dr. Bruce Peret is called Dimensional Thinking. And this is one of his kind of primer articles in the of RS2, the re-evaluation of the reciprocal system. Now, we started this article yesterday, and so if you want to catch up, you might want to watch yesterday's video. But we will be starting it in the middle here, starting here. By making rotation primary, a constant angular velocity, the photon could now be represented by a two-dimensional quantity, the complex number, with the real aspect being the translational speed of the outward progression and the imaginary aspect as a rotational operator to specify the angular velocity of the rotation. Now, if you're trying to scramble back and remember your Algebra 2 from high school, or whatever class that was, a complex number is the combination of a real number and an imaginary number. The imaginary numbers are I, especially I, but I, J, and K. They all are the square root of -1. They're not real numbers per se, but they do participate in a lot of equations, especially for magnetism and electricity. And what they basically are 90-degree rotations. And they are combined with a real number. So a complex number takes the form of A plus BI. So a real number like 1, and then plus BI, like plus 2i. 1 plus 2i is a complex number. And, you know, there are various rules of how to combine them that I'm not all that up to date on. But so that is what a complex number looks like, with the real aspect being the translational speed of the outward progression, or the progression of the natural reference system, and the imaginary aspect being a rotational operator to specify the angular velocity or frequency of the rotation. Nehru's concept was actually buried in Larson's own research concerning the idea of units of motion that represented 3 possible speed ranges of any specific motion. The basis of this is Larson's speed-energy relationship, where any motion could exist as either a unit of speed, 1 over n, or a unit of energy, n over 1, as a simple matter of arrangement, not requiring any addition or loss of energy to change between the two. Speed was Larson's first unit of motion, 1 minus x speed range. And energy was the second, 2 minus x range. Energy having its direction reversal in time, n over 1, the 1 being +1 minus 1 plus 1 equals 1, had to be expressed in equivalent space, which is a two-dimensional form of space representing the effect time has upon space. Speed in space was a linear translation, but because equivalent space was a second power function, speed in equivalent space is orbital, making equivalent space Larson's version of the imaginary number. Nehru's concept of rotation as primary is just Larson's motion in equivalent space. But this is still one or two-dimensional thinking. I think I forgot to mention that this article is called Dimensional Thinking. So that's why he's going back to this. But this is still one or two-dimensional thinking. In a three-dimensional universe, Larson's work is basically done on a number line where all values are real. Nehru extended Larson's work into the complex plane, giving two dimensions to motion. What happens if we take thinking up to three dimensions? The first thing we run into is an old problem from the 1800s that puzzled researchers into imaginary quantities. How to increase the rotational dimensions of the points on a plane of complex numbers into points on a sphere, where it becomes impossible to calculate the quotient of the coordinates of 2 points in space. This was resolved by William Hamilton in 1843 with his concept of the quaternion, a four-dimensional quantity that had a real scalar value coupled to a rotational triplet. 3 rotations, not 2. Make it work. It seems like it's 3 rotations, not 1. Make it work. Because a complex number just has 1 imaginary number, while a quaternion has 3 imaginary numbers. Moving on. Continued investigation found that there were only 4 dimensional structures that were solvable. 1, 2, 4, and 8 dimensions, known today as division algebra. Larson did attempt to take motion into a third unit through the use of his ultra-high speed range, incrementing the second unit of motion, energy, into the first unit, speed, of a second dimension of motion and reversing its scalar direction, though there is no conceptual reason why that would happen. Okay. Larson uses the ultra-high speed range primarily in the discussion of astronomical objects, where such motion can be observed. As a general concept, it works, but when applied to specific equations, fails for the same reasons. Hamilton ran into. But Hamilton's solution works just as well in the reciprocal system. All right, hello again, and I'm sorry that my phone overheated again mid-sentence, and I was close to being done anyway, so just wanted to say we will return tomorrow and finish up this paper, and stay tuned. Thanks for tuning in today, and have a good day.